Good. Okay. Okay. Welcome. Today I'm going to talk about 9 rules for porting Rust to the browser. The idea is you already have a running Rust program and you'd like it to run in the browser, and we'll see some nice things about that in a second. I got started on this because I have a crate called range set blaze, and I got a user request that somebody wanted to use it inside something that ran in the browser. So I did the port, took some notes, and now can offer advice. Here's an interactive section. If you click the QR code with your phone, you can run my Rust code in the browser of your phone. So try to do this myself. Oh, that's not going to work. Well, you can do it. This is a web app that finds the race results for your running club. So you have friends in your running club, there's some results from a local race, and you want to see if any of your friends are in those results. If you have a friend named Bob Smith, and there's a Bob Smith in the results, it may or may not be your friend. But if you have a friend with a more distinctive name, my last name is distinctive, Kadie, and you find it there, then it probably is your friend, Carl. Here's an example. Colleen, that match is worth about 6 points. D is worth 11 points. Her last name is worth 15, but the result has the runner living in Denver. Colleen's actually from Boulder, so you lose a few points for that. So this is all based on an engine that uses naive Bayes. All these numbers are in log odds space. It's all got some probability theory behind it. What's nice is by running this in the browser, hopefully on your own phone now, I'm running it, but you're paying for all the compute. And it's running on your phone, your laptop, your tablet, all that works out super easy. To run this, you have to send the program a list of your friends and where they live. This is all running in your browser. It never comes back to anybody else. So we bypass all privacy issues. And from the point of view of the hosting computer, this is all just static web page and static JavaScript and some other files. So GitHub is hosting this for free, and I didn't even have to ask them for permission. So this is all material from an article that you can find on medium.com. It's also about 1/3 of the material I gave at a workshop at the Rust conference in September in Montreal. Several people in the meetup have heard parts of this, so thanks to Chris, Connor, Ike, Jack, John, Priyanka, and Sandeep. The people in bold have already heard this part of it, so a special thanks to them because they're going to have to hear it again. I already gave you the introduction to me before. A couple things before we start the 9 rules. I'm going to go over some definitions. So if I say native, I mean your main desktop operating system like Linux, Windows, or Mac OS. We'll talk about the standard library, STUD. That's the thing that provides Rust core functionality, and you're probably familiar with string and vector. It's also what lets us do networking and file I/O and find out about the time. We're going to talk about WASM, which is short for WebAssembly. It's the thing that we can compile to instead of your native OS that'll let your code run in the browser, and some other places beyond the browser. If we talk about WASI, I think of that as an extension to WASM for running your code out of the browser that lets your code have some extra capabilities like file access and in the future, not too long from now, networking and better handling of time. Because we're running in the browser, we don't actually have these WASI features, but I'll still be mentioning them incidentally. Okay, we're going to go over the 9 rules one by one. Now I'm just going to kind of give you an overview of what they are. And the first thing is to make sure you have a running Rust program at all, like running on your native system, maybe running on WASM WASI. Also, sadly, the HTML stuff is going to have to be done in JavaScript. So you're going to have to be able to do at least enough JavaScript to create kind of a minimal program. Then you'll install some tools. We'll talk about those. You'll compile your project to a library, and a little bit different flavor of library than we usually do. You'll find out your program doesn't work because there's some limitations on what types you can use, and we'll learn what those are. You'll change your program to use just those types. Your program will work if you can run your tests. We'll adapt your tests so you can run them. Then you get everything set up, except you're going to have to make some of your dependencies compatible with what is available with this WASM JavaScript environment you're running in. Finally, you can connect the web page and have JavaScript functions calling parts of your Rust functions. And when we're all done, we'll put this all into continuous integration so it doesn't break down the road. So number one, I'm assuming you have like an executable program and you want to just be sure it can run on your machine. You might also want to check to see whether you can run your tests on WASM, which usually isn't that hard. And if you do these 3 steps, you can see if it runs. If it doesn't run, it's often because of problems like you were assuming a 64-bit machine and the WASM world is 32-bit. There might be some other things going on. You can read yet another article for some tips on that, or you can just skip that for now and hope that things work out as we move forward. What's the simplest JavaScript program that we can write that would kind of give us a framework that we can later add Rust to? So how about one that says line counter, and you click choose file, and you pick a file, and it loads the file, and it tells you how many lines of text are in it. And here's the full HTML JavaScript script for doing that. I'm just going to talk about the parts that are indicated here. There's a thing where the user, you'll get an event in JavaScript with a file or files. You'll take the first files, and you'll see if that's a null or not. If it's null, then the user didn't pick any files, and you'll want to do something to your output on the HTML page. If there is a file, then you want to create what's called a file reader, and then you do some setup, and then you tell the file reader to do read as text. And that says you want JavaScript to read the file as text. That'll be done asynchronously. When it finishes running, it'll call the code in the green box, and this is just JavaScript code for getting the result from the event that said it was done reading, splitting it on new lines, counting them, and then changing the HTML. So if you want, you can find this, you can use this code as your minimal JavaScript. And you can use, if you're using VS Code, it's very easy to interactively create this kind of page and just see the changes immediately on the side. Or there are also Rust local web servers that you can download. The article has some pointers to those. Okay, now we need to install some tools. So the first thing we're going to do is install Rust up, we'll say Rust up target WASM 32 unknown. So that's telling the Rust compiler that we want to be able to compile to a new computer type called WASM 32 unknown. The unknown part means that it doesn't have any special capabilities, and that's the flavor of WASM we need if we want to run in people's browsers. We'll also need some tools, which we can install with cargo install. So WASM pack, among other things, has the ability to package up a program and make it, set it up in a format that's usable by JavaScript. And WASM bindgen CLI defines the interface so that to the degree that it's possible, JavaScript can call Rust, can talk to Rust, and Rust can talk to JavaScript. Finally, and most importantly, and most vaguely, it's really good if you install Chrome for testing and Chrome driver. And it's hard. The reason you want to install this special version of Chrome is so that you can run your tests. And the reason you want to do that is because writing for the browser breaks the rule that if it compiles, it runs. And when you're writing for the browser, it'll compile, and then it'll start running, and then it will fail because there's some capability like opening a local file that you're not allowed to do, and the compiler didn't tell you. You only found out when you tried to run it. So you really want to do this testing, but it's kind of complicated. I've got it down to like 8 lines in Linux. I don't really expect you to read them there, but you can look at the article and hopefully get Chrome for testing and Chrome driver set up, which will let you do testing. Okay, so now we have our, now we want to change our program to make it in a form that's suitable so that JavaScript can call it. We need it to be a library. So the first thing we'll do is we'll rename, if we had a main.rs, we'll change it to lib.rs, and then we'll go into our cargo.toml, and we'll say, we'll put a lib section in. Something different than we used to do. We also have to give a crate type, because along with creating the usual Rust library type, which is rlib, we also want to create a C-compatible dynamic library type when we build it. Then you need to add a couple dependencies. WASM bindgen is the thing that lets you different types talk to each other across JavaScript and Rust, and WASM bindgen test is the thing that will let you run tests. Now we're going to create what's probably a new file. It was, I guess I'd seen it before, but I hadn't done it a lot. There's a .cargo config.toml file that's very easy to confuse with the cargo.toml that we always that we're all very familiar with. It's a different file. It's a file that lets you tell cargo how you want to test. In this case, it's telling you that if you're running a WASM32 test, that you want it to run this program to run the tests. So it just makes things more convenient to set that up. We're going to have to change the code a little bit. Any function that you think you want to make accessible to JavaScript, you should decorate with the WASM bindgen attribute. So I'm changing projects here. This is a function called good Turing that does some kind of statistical analysis on the text of a file. The current version of it, the first version of it, takes a file name, reads the file in by turning it into a buff reader, and if does some more processing not shown here. If everything works, it'll return 2 numbers, and if there's a problem, it'll return an IO error. So for now, we'll just mark that as we want it. We'll have to put a use statement up at the top to include the WASM bindgen types, and then if we have any test code, we'll also include this use statement you see down at the bottom to give us access to the right methods in the test code. And there's also a macro that configures the tests to literally run inside the browser. So we do all this, and it doesn't work. And the reason it doesn't work, well, there are a couple of reasons. First, we were returning, when things worked well in our happy path, we were returning a tuple, a pair of 2 numbers. JavaScript doesn't like tuples. They're not allowed. And if things don't go well, we're returning an error object of type IO error. It doesn't know what that is, and it doesn't allow that either. Okay, we'll see in a slide or two how to fix that. Even after we fix it and run it, it's still going to fail. And that's because the first thing we were doing was trying to load a file from our local disk. And for security reasons, you're not allowed to put code in someone else's browser that reads files from their local disk. Not unreasonable. So let's talk about, we said we're not allowed to use tuples and that error thing was bad. What types are we allowed to use? So we're allowed to use all the kind of simple, we call them the copy types, the numeric types, the integers, floats, bool. You can use use64 and i64, the 64-bit integers. But on the JavaScript side, you have to use a special library, but they're still available. You'll notice the 128-bit integers aren't available. And we'll see that again on the next slide. Thank goodness we can use vector and string, because honestly, if you can do vector and string, you can do anything, right? There is a problem with that. JavaScript, say, wants to pass a string to your Rust function. The way Java represents a string and the way Rust represents a string, they're not just different kind of in who controls the memory. The actual format is different. JavaScript keeps things in 16-bit Unicode, and Rust is 8-bit, but if you ask for a single character, it turns it to 4 bits. It's more modern. But anyway, they're different. It's going to copy it. Likewise, if you give it a vector of bytes, where they are the same format, it's still going to copy it. You can pass a slice of a string or a slice of bytes. That works fine, but it'll still copy it when from Rust to JavaScript, JavaScript to Rust. You can think, okay, maybe I can avoid all this copying by passing it a mutable slice of bytes, because then I'm like telling Rust, just trust JavaScript, and you don't have to control this memory. It will copy it, let you mutate it, and then when it goes back to JavaScript, it'll copy it yet again. So that's what, 3 copies all together. So things work, but there's going to be some inefficiencies in this process. A very nice thing is that we can use a couple of our favorite Rust types, option and result. And especially, now of course, on the Rust side, there are wonderful things that stop us from making mistakes. Because we want the JavaScript to be written idiomatically, on the JavaScript side, they'll be very prone to errors. So an option none on the Rust side will get turned into just a nil on the JavaScript side, and a sum of 4 on the Rust side will just be turned into 4 on the JavaScript side. But you're programming in JavaScript. It's what you expect. You can even send results back, and should, from Rust to JavaScript. On the JavaScript side, if it's the happy path, then you'll just get the happy result. If it's the bad path, it'll throw an exception with your error type, but your error type is restricted. I recommend you just make it a string. But still, it's JavaScript, try, catch, all that works the way you would expect it to on the JavaScript side. The thing that surprised me maybe the most is that Rust structs can be passed over to JavaScript, and you can manipulate them in JavaScript as long as you mark the methods that you want to manipulate them with that bindgen attribute. Not as nice is in Rust. We love our enums as much as our structs. They're not supported if they include any data. They can only be simple enums with fixed number of variants. So a C compatible enum equivalent to an integer. JavaScript also has kind of a type that can represent anything, which on the Rust side we call JS value. And you can query it. Are you a string? Are you a floating point number? Are you an integer? If you are, tell me what your string value is. And Rust can do all that, and can even create one and pass it to JavaScript if it wants. This is the yep list. Here's the nopes. You can't pass these simple types by reference, but who cares? Because if it's only a short number, you can just pass the number. You can't output a slice of strings or bytes. And the reason is because now we'd have 2 different things owning the memory and controlling it. So that's just not allowed. You can't you can't pass a string with a mutated, and then have the caller get it back. But you can pass a non-mutatable string, do whatever you want to it, and then just pass it as back as the result. So you can get around any problems. No 128-bit integers. You can't have fixed length arrays, and you can't have tuples, but we already saw you can have vectors. So that's a fine workaround. Both JavaScript and Rust have maps and sets, very handy data structures, but there's no conversion done for you. So there's no easy way to use those across the calling boundary. 2, 3, I guess, types that you can use, but you should not use are usize and isize. And that's because you probably think they're 64-bit, but on the JavaScript side, running in WASM, they're going to be 32-bit. So you're just going to cause confusion. Likewise, the character type in Rust is a 4-bit thing, but only some values are allowed. JavaScript will just turn that into a string that just happens to have a length of 1, and it's not checking anything in particular. I think you'd do better just to use a string, and things would be safer. Okay, so now we're gonna make two changes to the good Turing function we had before. First, instead of passing in the name of a file and trying to open it, we're going to pass in a buffer reader where presumably the file's already been opened. And everything else we're going to leave the same. So this is still a perfectly good function for our Rust code that might want to use it to use. You just have to open the file now before you call it. I didn't want to make any other changes to make it nice with JavaScript because I still wanted to have a nice Rust function. So to create a function that JavaScript is happier with, I'm going to create a wrapper function called goodTuring byte slice, where we pass in a slice of bytes. And now instead of returning a tuple and an error message, we return a vector of numbers and a string if there's an error. When we get this byte array, we turn that byte array into a buffer reader. Then we call our preferred function, the one above. We'll get a result back. If the result's on the happy path, we turn the pair of numbers into a vector of numbers. If it's on the sad path, we turn the IO error into a string with the same message that we would see in the debugger and send that back. One thing I want to point out is both these functions are perfectly good Rust functions, and both can be called from anywhere else in your Rust code. Which means we can create tests. So first of all, our regular test is we only have to make a small change in the test we presumably had before to check some answer. Still works. For the new function test good Turing byte slice, we'll still decorate it with pound test because it's still a perfectly good Rust function that we can test when we run our tests natively. But it can also be a WASM bindgen test, which will actually run in the browser. And we can call the function and see that it gets the numbers we expect. And I don't think, if you look at the documentation for this WASM stuff in Rust, I hadn't seen other people noticing that the same function could be a test in both frameworks. Before I noticed this and got it working, I would duplicate all my tests, which is a terrible thing to do. And this is much, much better. When you run this, you might have some problems. For example, if you're using a random number generator, the WASM isn't going to like that, but there's a crate you can use called getRandom that'll just make it work. If you're using some time functions, those won't work, but there's a crate called WebTime that might just work. These are the only ones I've needed so far. There are other ones that seem popular. There's one called request, where your Rust can actually make HTTP network requests. And it does that by calling back through WASM, which then calls back through your browser, which makes the call. I don't know how well that works. There's something called plotters that obviously does plotting, but also seems to have the ability to control the canvas on the HTML, which means you might have more than just passing numbers and text, which is all I'm doing. And there's something called glue, which is a toolkit that tries to make as much of the JavaScript capabilities as possible accessible inside Rust. I wasn't that interested in that because it was more for me getting the Rust accessible to JavaScript. When you do all this, you can run cargo test and run cargo test with the target of WASM 32 unknown unknown and see that your code is working. Okay, so now we want to connect our web page and actually have it call these functions in our Rust package. And we can use the WASM pack tool to do that, and it'll create some files that the page will look at. Now, then we'll update our web page, say index.html, and our goal is to have it calling good Turing byte slice, pass in some bytes, and handle errors. And let me just talk about some of the changes we need to make. So at the top, you'll see we need to import both an init function and our function good Turing byte slice, and the location, it was put there by that packaging thing we saw just a second ago. Number two, as often as we want, but before we call the function we care about, we need to call init asynchronously. And it's okay to call it multiple times. It'll only do the init the first time. Before we set up in JavaScript a reader thing and it said read as text. Now we want to set up a reader, but for this application, I want to read as a array buffer. And that's in JavaScript. And that's after we did a bunch of setup. Then inside that onload await, we get the bytes from after the user has selected a file, and there's only one file. And then we call the Rust function with the bytes. We'll get the two numbers out as a vector, and we'll output the appropriate HTML. But all this was also in a try-catch. So if there was an error, we'll catch the error, and we'll put out the appropriate code there. And you can actually test this. And I can't because I turned off my cursor. So if you test this and select a file, it'll try to guess how many unique words are on the even lines of the text file you gave it, but it's only going to look at how many words were on the odd numbered lines. This is something that Alan Turing and I.J. Good were working as part of their decryption work during World War II. Okay, we're close to the end. I've got a saying, if it's not in continuous integration, it doesn't exist. So if you've ported your code over and got it running and you're very happy, and then you forget about this and you keep working on your library and do other things, this JavaScript compatibility stuff will invariably break. So it's important that whatever continuous integration you're using, like GitHub Actions is the one I use, has tests in, so that every time you make a change in the future to your Rust program, it'll check to make sure your JavaScript, your WASM tests still run. And that's not hard. There's too much to show here, so you have to look at the article. Okay, so last slide. Just in reflection, what's bad and then what's good. The bad part is testing is kind of annoying, and I'm sure a lot of people don't do it. Even though they should. And it's because Chrome for testing is hard to install and hard to manage because it's kind of incompatible with your normal Chrome. Another thing that's bad is we love if it compiles, it works. And now that's not true because they wanted to make WASM as easy to use as possible. They pretended it had the full standard library. And in places where it doesn't, you won't know until you try to use it and it fails. It's nice that it can pass strings and vectors. It's too bad that it's always making 2 copies at least of your memory. It'd be fun if there was a way you could like just pass a slice of memory and not have to make a copy. The good. This is fun. You can take a Rust program like my calculator for running results and just put it on the web and host it for free. And even though I had like colors and things on that little JavaScript thing, I don't know how to program JavaScript. For these kind of superficial JavaScript things, UI things that you need to do, the AI agents are really good at helping you learn that much JavaScript because it's not a lot. And as we saw, you can run not your regular tests. Even the code that you made to make especially compatible for JavaScript, you can run it both natively and you can run it as a test in the browser on your desktop when you're testing. And the good, I said it was bad that it compiles, it works, doesn't work, but it's nice that you can use most of the standard library. If we move on to embedded, which was the last third of the workshop I gave, then you have to go out and strip all the stuff from the standard library away. And that made things much harder. So this makes things easy. And yet another QR code, and this one's to the article. Okay, thank you. And any questions? Yeah. I don't know for sure. I think if it's a CPU intensive thing in Rust, it's only going to be single threaded. It'll be in their browser, but it's still going to be, I mean, people think WASM is pretty performant. Of course, copying the complete works of Shakespeare, which is what I'm doing here, as a string, that's not efficient. But the CPU stuff maybe is acceptable. And you see people doing in-body simulations and things in WASM. I don't know if they're doing it in Rust. Oh, sorry. The question was, how much performance would you expect to lose by running your Rust in WASM? And yeah.
add a little bit to that you actually get surprisingly good performance, but the main hits to your performance in WASM are going to be obviously excessive copying from, across the REST WASM boundary, but also whenever WASM needs to interact with the UI, generally it's going to go through the DOM. And so you lose a lot of speed there. There is work in the industry to either flip that or remove that dependency to let WASM achieve its full potential. But if WASM has to talk to the UI, or if WASM has to talk to Rust, if certainly the UI is going to be can be inefficient, but if you're careful with your data types talking to Rust, you'll have to get around the issues that Carl pointed out. But it's surprisingly good performance.
Okay, thank you.